and Elisabeth for this panel. Guys, we are really in the home stretch now. Fabian will speak in the end, but the last keynote is from someone who is more or less inventor at the rise of AI. He taught students in the major universities of Stuttgart, Saarland and Stanford. Professor Hans Uszkoreit will tell us beyond algorithms, and please give a warm welcome to our good friend, Professor Hans Uszkoreit.
Danke. Yes, thank you so much for the introduction. What a day of information, lots of interesting compacted stuff on the next generation of AI and the current generation of AI, and most of it is on algorithms. So why would I say that there is an end to that? What's beyond algorithms? Yeah? Why should we stop? No, it's not that algorithms will stop. But I want to concentrate really today on a revolution that is not really dependent on new algorithms, that will happen anyway. Yeah? So that's my field. But for the moment, for the time being, let's get back to algorithms. So those have been the major, or some of the major neural network architectures before 2017. Many of them, I mean, you know them, yeah? They have been behind things like Alexa and Google Translate and so on. Very powerful things. And then 2017, the transformer came. That is what most of the talks today were on. So actually large language models, generative AI, that started with the transformer. What it brought in new was this mechanism of self-attention, multi-head self-attention. But it lost memory, for instance, yeah, that we already had in LSTMs. But it brought in parallelization, which was not possible with the recurrent networks. Yeah? So it's a give and take. So, and now algorithm research is really concentrating on two major areas. I will point out both of them, and then leave the algorithms and talk about my favorite topic. So one of them is, that was mentioned today so many times, is it became clear that the systems themselves, yeah, they can be asked, the neural networks, the large language models, the transformers, they can give smart replies, but they have no agency. They cannot themselves do any planning and automating. So the agency needs to be done outside of the AI, which also has some advantages and disadvantages. So most of the research now in applications is in this wide field of agent. Yeah? And usually this is now a very abstract way. Yeah? So there is then a non-AI agent. Usually there can be some AI in it, but usually it's mainly the core of it is not really AI, that accesses one or several LLMs, but can also access databases, do RAG, look up other things, look up a secondary LLM and compare them, work with knowledge graphs and different apps and so on. So this is this agent systems. Yeah? Those are the majority of applications somehow fall in there. Most of them are simpler. And the next big thing, and actually Pascal today, she talked about it without mentioning it. She only said, oh, we are building these agents. What she didn't really say is that Meta is one of the places on Earth where people now work on the new generation, what comes after the transformer, namely combining a system that has the power of self-attention, bringing together in a huge context window, learning dependencies over long stretches of context automatically, plus memory and agency. If you have memory and agency, Then you can also build in action models, planning, with agency and so on. Then you can do other things. You can have situation models, and in the end, maybe a world model, if you get data also from the world or from movies or whatsoever. So this is the next architecture. So the algorithm research is in these two areas. Most people, 99%, work on the agent architectures or on the embedding of the LLMs now in industrial or other societal applications. And then there are some people who are working on the next generation. So now back to non-algorithms. That was about algorithms. Yeah? Let's make a thought experiment. Yeah? I mean, just think about it. Think about for a moment there would be a ban on algorithm research. From tomorrow on is a death penalty for any new algorithm. So people stop doing algorithm. Thought experiment. Will AI stop in being exactly what it is now? Or will it still develop? What do you think? I think it will still develop, and I will point out why. Because it is actually not the algorithms right now, I will point this out, that drives progress right now, because nobody is working on the new models of tomorrow yet. So let's get briefly, so this is the data volume for GPT-4. You know some of the numbers. Yeah. The important number here for me today is not the parameters, but the tokens used for training, because they would be equivalent to 100 million books. But actually, there's not even 1 million books in this system, yeah, probably. We may be mistaken, we don't know. But if there is, maybe 1 or 2 million, but not so many. So what happens? Why don't they put in all the books? Yeah? I come back to that point, very important to note. So then we have the new Llama 4, a little bigger in parameters, and now 30 million tokens. That's equivalent to 216 million books of 200 pages each, yeah? So about. But this time, Meta does not want people to know exactly how many books are there in there, because they get sued already over books. Yeah? They got several lawsuits now. So but the idea is that probably LibGen with 7 million books is in there, probably also books 3, maybe books 2. And so there's a couple of book collections in there, maybe 8, 9 million, we don't know. So the observation now is that since 2022, most major progress that we are talking about is not due to new algorithms. Because what is OpenAI using? It's a simplified version of the transformer, yeah? And Google were cranking out, the Google people, more and more algorithms going to the major conferences, and the OpenAI people collected more and more data and put them in, and for a while they were winning the race. Until now, Google is catching up and also doing this game of bringing in more and more data. Yeah? So it's actually the teaching more data, not the new algorithms, that make the progress. So when machine learning is the following, it's the following discipline. It says you have a problem and then you have available data. Now find the best algorithm for solving, for learning from these data, and be able to deal with new data for classification, translation, summarization, whatever. Yeah? So then is machine teaching is a different discipline. It's a discipline given an algorithm, maybe the most powerful transformer. How can you teach this with data? Not just the quality of the data, but also how you feed them, how you benchmark, how you test, how you increment, how you check, and so on. So the whole teaching thing, yeah? So machine teaching. So it's actually a new trans-discipline. I will not say so much about it, but the discipline is not there, as you know. There are, but which computer science course? Many of you have done computer science, yeah? Which computer science course teaches you this? Is it 1, 2, or 3, or database? No, none. People in computer science don't learn about copyright, about how to deal with publishing houses, where the disciplines are, what's the categorization of information. That's information science a discipline that has a bad name, has gotten a bad name for no reason. So this is a little example that is only achieved actually by, many of you know this thing. That's a difference between GPT 3.5 when it comes to certain aptitude tests in fields. Undergraduates take these aptitude placement tests, and what was achieved in GPT-4 by picking the right training material next time so that the system would be better. There's no new algorithm in there. All this progress is only done by different data. So, and there are many examples like the chain of thought. That's clearly, much of the chain of thought thing is not reflected in the machine learning algorithm. It is actually a way of presenting and learning data and learning steps, or the deep-seek reinforcement learning jump. It's machine teaching, not machine learning. Or, for instance, the recent result where people discovered why the systems are so verbose, overly verbose. It has to do with reinforcement learning. They get a penalty on the percentage of words that are wrong, that are bad, and if you put out more, you reduce, of course, the proportion that's smaller. That was discovered as an afterthought. Some people were able to prove that, So it's quite interesting because you didn't limit it. So it's on teaching, it's education, it's not algorithms. Or the recent research that Pascal Fong, who talked this morning, did on hallucination, where she pointed out, rightly so, that lots of stuff that was called hallucination are actually just missing knowledge, and the real hallucination is a much smaller set. And what we discovered is also you can almost get rid of hallucination. Have you ever heard of a LLM that hallucinated a 13th month of the year? No. Because there's enough evidence. It will never happen. So if you have more secured knowledge, you get rid of hallucination. Don't worry about it too much. So this is this part. And additional types of data will come in. That's not only part. Here is, I have to be careful, it's not only machine teaching, because very often you need to find substitutes for the tokenization, for the vectorization of the data. So it goes. Here's already some algorithm work also needed. Okay, but now come back to my point. So for many, many centuries, millennia, lots of researchers and other people gathered knowledge, the knowledge of mankind. And you can assume that's in many libraries. So for long, it was in the monasteries, later in libraries, distributed. Now lots of it is on the web. That's the knowledge of all mankind. How many books are there? Question. So Google Books, they did a calculation. They gave not just a rounded number and a very exact number, which I thought was crazy because nobody can say it. They came in 14 years ago, they counted up to 129 million books. Now every year between 2.7 million and 3 million are published. So that means we are now more than 150 million books ever written. So that's by studying history, historians, that's the best of all of our knowledge. 150, maybe a little more, million books were ever published. So. But nowadays, people don't go to libraries that often, but lots of knowledge has been stored in big knowledge repositories, and knowledge about different things. And this knowledge, together with the books and other stuff there, is important, like regulations, patents, standards that are not there, enterprise periodicals. They really, all that stuff together is the knowledge of our civilization. Another thought experiment for a moment. From tomorrow on, all of our children are raised by robots, and they are not allowed any access to knowledge. They are raised by robots, very nice robots. They get enough food, don't worry. So the kids are treated very well. They can play all day. They don't have to learn anything. They play all day. What would happen after a generation, after all of us are dead? It's the end of civilization. They would have to rediscover language which works, by the way. There's experiments, the Nicaragua experiments. There's experiments, not unethical experiments. Yeah? There were people, disabled children who developed their own language. Yeah? So children develop a language within already one generation, a simple language, not yet a full-blown language. So they would come up with a completely new language, and it would take them probably as long as it took us. There's no way why it should be faster, because if the robots don't tell them anything. Yeah? So that means it's the end of everything. It's the end of civilization of everything. So this stuff is very important. So the knowledge of human civilization, and there's a little bit of that dropping into our little heads. So each of us can by any expert that who reads many, many books, can get about 100,000th part of the human knowledge. Maximum, probably more like a 300,000th part, because it's too much. Yeah? So each of us. So we cannot solve many things, and we need to get together, do interdisciplinary research and committees, and in order to, because our brains are too small. So a short detour on the books, and then I come back to that point. So Llama 3 and 4, they got sued now by authors. And these authors said, you are training our books, you are making, so some of these, the first one, Coates is a political writer, kind of, Sarah Silverman is a comedian, and Adam Neville is a horror fiction writer, horror fiction. And especially Adam Neville said, I take them to court. Because I heard one Meta person say that a book can maximally improve the performance of the system by 0.06%, which is absolutely crazy. I don't know who said this. I mean, he should be punished. He should be fired for that tomorrow from Meta, because it's not right, and also it leads him on the wrong way. So then he said, I want 0.06% of all the money that Meta makes with this model. Actually, he was dumber than that. He said, I want 0.06% of the money that was invested in it, which is, okay, but it doesn't matter. He's a horror writer, so you cannot, what can you expect? So, this is an interesting story, right? So people are trying. So instead of authors coming and saying, oh, if the knowledge of all mankind will be concentrated in one big AI system, I want to be in. Please take my books in. These people, they say, oh, I want to make money now. I want to. But actually, if you really calculate, for yourself, if you calculate how much do you think OpenAI made so far with a model, and then subtract all the costs that AI had for computing for their people, and take the little margin and then divide it by the number of pages, by the 13 trillion words, the people would not get much. So I think it's an illusion. But it's interesting. So, and there's right now an interesting paradoxon, I call it the knowledge paradoxon. And the knowledge paradoxon is the following. In every field, we measured it, for instance, with a master thesis together with data from a big car company in automotive. It doesn't matter whether you take automotive or any large field. If you take a test, if a human takes a knowledge test in that field, will always lose against the big systems, because nobody knows so many fields. Even automotive engineering is too big. The battery person does not know enough about the gear shift and about the engine, so we are losing. But in any real concentrated fields, human experts are better, and moreover, the systems are usually not reliable and good enough for knowledge-rich tasks in that field. So they are, even if they have all this broad knowledge, they would win every competition and TV show, but when it really comes to fulfilling they are not yet good enough, so they need to be post-trained. Oh, that's the automotive that we did. I won't want to bother you. So how can you then make the model know more and get it in? So let's take the three things in the middle. You do supervised fine-tuning, you already know. You can do some reinforcement learning. That's not really on input-output pairs. This is more to tune and improve, not really to teach it new knowledge, but to improve the return. And then you can do continued pre-training, which is very difficult because usually very few models give you the checkpoints that you can go back and continue the pre-training. Also, it's very risky. If you do it wrong, you can get catastrophic forgetting, and the system, because with new conflicting biases, it destroys already learned knowledge. And so you have the costs of having your own instance plus the risk of ruining everything, yeah, and losing all your computation. So most people are too scared to try it, but there are some people trying it with smaller things in the academic area for other languages and so on. And then you could do adaptive pre-training. So what's the one on the left? That's interesting. That is, if you do not want to change the model because the context window has become so big, why not teach the model for a nanosecond and make it very knowledgeable in my field, yeah, for a nano, because right now you can get up to 2 million or 32,000 with GPT-4, 2 million with Gemini 2, and then you teach it, and after that the system has forgotten. This is also very useful if you have confidential information that you don't want the system to memorize, yeah? So that's also good for that. And actually, there are people doing it. There's a company, for instance, that Faye and I are investing some help. We are helping them, assisting them, doing that. They do this quite a bit. So they teach, for teaching the model, facts, concepts, formats, and extending the prompts. And then you need a mechanism that does the teaching on the fly. That's not easy because you cannot teach it all of the field if you in every prompt put in all the automotive engineering books. That would be too much. But you need to find that part of knowledge that's needed for that task. And actually they are quite good with that. And so how would we call this? But now they give it a funny name. They call it dynamic hybrid language model. They say the model together with all these prompting libraries and so templates, filling it. They are using ontologies, knowledge graphs. Very clever company, very, very clever company. Very good customers already, very successful in a short time, grew very quickly. But the name is of course not right. This is not a model that comes out, but it sounds good, right? Hybrid, it sounds very good. The model, and I will not talk much about domain adaptive pre-training. This is really an interesting thing, how you get models. But let me tell you one thing, there is probably a business idea for the big model producers that they have not gotten into yet. And this is providing the possibility, probably even on-premise or in a private cloud, to do under their guidance, yeah, the people who produce the base system, helping a big corporation to do this kind of adaptation, yeah? Adapting the model and doing, because they can do it better than anybody else, and they could sell that, because the company themselves, they don't need it every day, yeah? So why should they hire all the staff doing it? So this is a very good business idea for the future. So now the question, another question. We talked about the knowledge of of civilization, and we saw it fits already if we had it, if we had the possibility of getting all the right books and paying for it, because that's of course why OpenAI didn't do it, yeah, because it's too expensive. It didn't pay for the books, and neither did Llama generally. Yeah? But if somebody would do it, would this system stick with that knowledge, or could it, like humans, develop more knowledge? So we know that there are researchers who don't do any own experiments and who don't go to Africa or to the space in order to gather new data, who only work on secondary research. They produce new research out of the results of others and the measurement. Yeah? Lots of stuff can be done that way in almost every field. Some fields are better, some others. Yes, I think if we get the system in a kind of chain of thought or multiple call, slow way of getting and doing it? Yes, I mean, I tried it myself in a field that I'm not very good at, yeah? And it discovered things that neither the internet nor the system before had. Yeah, that were only discovered because I asked it certain questions and it discovered new knowledge. So there is lots of stuff to be gained that way, yeah? So lots of stuff. And let me finish now. Oh, yeah, I should finish. Some notes on the impact. I hope that you already saw it yourself. If not, I will tell you. Yeah? There's a huge impact here. If you really get the compression of human knowledge into such a system, and it becomes more reliable, and it's trained on good data, much better data, and is much more reliable, it will change everything. Because thought experiment, think already, it's there. It's there, you can reach it every day. Everybody would use the system right now. We are already, everybody is using already the imperfect system, but then everybody would use it every time. So all students, everybody in school, that would be the authoritative source. And authoritative, we have to be careful because some countries would make it authoritarian instead of authoritative. Yeah? They would say, we have aligned the system to the ideology of our country, you have to use it. Never write anything else. Yeah? So it's a danger in there too. It's a danger because our system should reflect the multiplicity of ideas and opinions. It should be a multiple viewpoint system. But if you can do it, right now it is. Yeah? It always gives you arguments for and against, for instance. Right now it is. And now think about the following thing. Today, a robot does not need an onboard brain. The brain can be some other place, right? Doesn't, because it's connected to the brain. I mean, we don't need an onboard. No, we need, because we don't know how to get the nervous system be connected. But maybe future medicine will connect us to an outside brain, yeah? So if our brain gets smashed or so, maybe we get our brain outside. But right now we cannot do it, but every system can. What does that mean? If that system is a commodity, affordable commodity, every little thing, even my toaster can be smarter than me. Yeah, so, I mean, think about it. It's cheap. Everything in the world, every robot, everything in the world can be as smart as all of mankind, have the combined. And this will be such a revolution. Every robot will be so super smart and know everything. I mean, think about it, think it through. This will be the real revolution, and it doesn't require any new algorithms. So, okay, so so what would it mean? The little bit of knowledge that we have still, new knowledge, that is not yet in there, will be very expensive. Because that is the only thing that we have still for ourselves. Every new knowledge will be immensely expensive. Yeah? So that will come out of that. Yeah, will be. So, and then the last thing, sorry for the 10 seconds. Yeah? Sorry. So, also we should rethink, and I think in automation, people who worry about automating things with AI are already starting this process. We have to rethink what our real value is as human beings. We thought that our value is that we can do differential diagnosis, that we can that we can have a stylistic top-level translation, that we can write a wonderful report or application. No, all that stuff can be done by the machine better. If it can play chess and Go, why shouldn't it write good reports? If it can write poems and do everything. No, all of these. And still, we don't have a system that replaces a full job. Yeah? Almost no job is in full replaced. Why? Because we overestimated our knowledge, which can be copied, and we overestimated our performance in selected tasks that are the most, because they were the most challenging, we took them, yeah, because they were good selectors. But actually today, our ability to handle with angry customers and manage exceptions and talk to people and keep others happy, that no system can do. So it's a completely change of what is important. What really makes our real value is not whether we can compose or write a good compose. Yeah, maybe there's aesthetics, but whether we can write a good report or do a good differential diagnosis. So that's really important. Yeah. So it's our holistic capacity to deal with unforeseen situations. Because if you have a model trained at let's thought experiment for a moment. Yeah, think about the following. For 10 years, we put a system at every DAX 40 CEO desk, and the system learns everything what the CEO read and did and what the decisions were. Will the system be able to tomorrow take over the CEO role? No. Why not? We live in a dynamic world. The next morning, Trump has raised the tariffs. The people do go on strike. There's a shortage. We live in a completely dynamic world. Therefore, okay, now I finish. I get the signal. So therefore, our real value is in dealing with a dynamic and complex world and with other people, yeah, and doing that. That's our thing. Not doing the kind of stuff that we are tested for in school. Thank you very much for your attention.
Thank you, Hans.